Now to see the circuit connection for buzzer interface in Tinkercad, open your Tinkercad account, click on create and then circuit. It will open up a new blank space for you to create a circuit. Now change the name of your file with interfacing buzzer. Click on enter and you will see that the name of your project has changed. Select the components required to make this circuit, which is a battery to provide power and a buzzer. Here particularly is a piezo buzzer. As you can see on this box that this is a piezo type of buzzer. There are so many different types of buzzer available. This is specifically a piezo buzzer. Now you can see here it has two terminals. First one is positive, the second one is negative. So positive one always goes to the positive terminal of battery and negative of this goes to the negative of battery. Change the color of wire with black and this with the red wire. Now buzzer is an element used to produce a buzzing sound. Means these kind of elements are used in alarming purpose or in security and safety circuits. To see the result, click on to start simulation and you will see that your buzzer has started buzzing sound. As soon as you click on to stop, it will stop producing a buzzing sound. So, and this suggests a buzzer in off mode. So this is how you can connect a buzzer with power source of 9 volt of battery. We are going to connect a DC motor with a power source in Tinkercad. So first of all, open your Tinkercad account and click on to create and then circuits. It will open up a blank space for you to create your circuit. So we are going to connect a DC motor. So I'll write a name as connecting DC motor with source. Click on to enter and you will see that the name of your project is changed. Now for this particular experiment we are going to need a 9 volt of battery and a small DC motor. So this kind of DC motor. So this is used to provide power to DC motor and this is a DC motor. So as you can see here, this DC motor has a rotary part, means it is a rotary part which is going to rotate whenever you will connect it with a supply. It has two terminals. This is a terminal 1 and this is a terminal 2. As you can see here, it has not specified with the polarities, means which is positive terminal and which one is the negative terminal. So we will see it by connecting it. So first let's just connect the terminals. Connect this terminal 2 with the negative of battery using a black jumper wire and connect this terminal 1 with the positive terminal of battery using a red wire. But as you can see here that these two terminals has different colors. Observe it and you will see that it has two different colors. First is red and the another one is black. So now we will see that we have changed the connections. So what happens when you start simulation or you start the power source? Now click on to the start simulation. So let me first introduce you with the DC motor. So this is a motor which uses a DC power source, means it operates only on direct current. It does not operate when you provide it with alternating current. So this is a rotary machine which uses or which acquires current in DC form. It is a rotary machine which produces mechanical energy when you provide it with electrical energy. So this is a machine which converts electrical energy into mechanical energy. So whatever you are connecting here, means there is a rotary part over here, and if you are connecting a shaft or wheel or whichever the module or thing you want to rotate, will start rotating after you supply it with a DC source. Now let's just click onto a start simulation button, and you can see that it has RPM. RPM stands for rotation per minutes. Means it is the, you can see in other terms, as a speed of your DC motor. Means it has this much of rotations, 17,568 rotations in a single minute. Means it is rotating this much time in a time of 1 minute. So in 1 minute, it completes 17,568 rotations. But in the before this RPM, it has a negative sign. This negative sign suggests that your motor is rotating in the opposite direction, which it is made, it has a positive and negative direction. Means your motor now is rotating in the reverse direction, means you can see in anti-clockwise. Observe it carefully and you will see that it is rotating in the anti-clockwise direction, and also this sign of negative polarity shows that your motor is rotating in the reverse direction. Now just click on to stop simulation and just change over the connections. Means whatever you have connected over here, connect it here, and this to here. Means your this black terminal goes to the negative terminal of battery, and this red gets connected to the positive terminal of battery. Now click on to start simulation, and now you can see that your motor is rotating in clockwise direction, and also it does not have any negative sign before its value. So you can say that your motor is rotating in the forward direction or in clockwise direction. So whatever the thing you gonna connect onto it, rotor, it will start rotating. Whether you connect a wheel or you connect a shaft or anything, it will start rotating in clockwise direction, and if you change the connection, it will be in the anti-clockwise direction. So this is how your motor works. By changing over its terminals or its connection with source, it changes its rotation direction. If you are changing the if you are reversing the terminals, it will rotate in reverse direction, and if you connect in proper terminal with proper terminal of power source, it will rotate in the forward direction. So here we are going to make a fun project, also a project which are used, or you can use it in your house as a doorbell circuit. So yes, today we are going to make a doorbell circuit in Tinkercad. So to make this circuit in Tinkercad, first open your Tinkercad account. Then click on to create and then circuit. It will open up a new space for you to create a circuit. Now we are making a doorbell circuit. So I am changing the name of this project as a doorbell circuit. Click on to enter and you will see the change of name. First of all, collect all the components you are going to require to build this circuit. So first, take a breadboard, a 9-volt battery to supply a power. To provide the power to the circuit, now a red LED, a resistor of 500 ohms. Then we are going to need a push button and a buzzer. So just collect all these equipments. Now connect the negative rail of breadboard to the negative of battery and positive to the positive of battery. Change the color of wires with black and this one with a red wire. Now place your LED here and your push button, your buzzer here. Place the push button here. Place your push button here. And now we will connect all the parts together. So first we will connect the LED's cathode, this cathode terminal of LED with the negative rail of breadboard via a 500 ohms of resistor. So connect the resistor, something like its one terminal goes to the cathode of LED and one terminal is gets connected with the negative of rail. So now its cathode is connected to negative rail of breadboard. Now we will connect this anode terminal of your LED. This is LED's anode terminal and this anode terminal will get connected to the 1B terminal of buzzer. And this with, sorry, and the positive terminal of buzzer with a 1B terminal of your push button also. So we have connected a push button with buzzer and LED. Now this negative terminal of buzzer will be connected to the negative of breadboard. Negative of breadboard. So this is a negative connection, hence I have used a black wire. Now the circuit is almost done. The one thing which is left is to provide a push button with a power. So we have used a 1B terminal over here. So we will use this second terminal 2A. And for that I'll use a red wire. So connect this 2A terminal of your push button with a positive rail of breadboard. So first we have connected the LED, then buzzer, then push button. Now your circuit for doorbell is completed. Now it's time to simulate your circuit. So just click on to start simulation and you will see that as soon as you press a push button, your buzzer starts buzzing and LED is turned off. So this kind of circuit is used in homes and also for a security purpose. So it is how I have named it as a doorbell circuit. Why? Because this is the similar connection which is shown in our house. In our house, whatever, whoever coming from outside, for example your guest or anyone, is just pressing a switch which is outside of your house, and by pressing it, it will produce a sound into your house, and this will give you signal that someone is out there or someone is there at the door, hence it is a doorbell circuit. So I'm pressing a button here and it is started producing a buzzing sound and LED is turned on, hence it is a doorbell circuit. So this was a typical doorbell circuit which is used in house also.